Okay, so good afternoon. Today we'll be looking at chemistry, and in particular, we'll be looking at the acid bases and salts. Yeah, this topic is a very vital topic because most of the times in our homes, in our workplaces, hospitals, to mention by just a few, we apply the concept of acid bases and salts. So, without wasting much of the time, I want us to look at the salts themselves. We know what acids are, we know what bases are. So today I just want to focus on the salts. We understand what a salt is, the types of salts. Then later we can also look at the methods that we can use to prepare salts. Are they soluble salts? Are they insoluble salts? If they are soluble salts, what method can you use? And if it is a soluble or insoluble salt, what method can we use? So let's look at the salt. Now, what is a salt? By definition, a salt is a compound formed when when O or part of a hydrogen atoms are displaced. Are displaced by a metal or ammonium ion. So we're saying a salt. This is just a compound that is formed when part or all of the hydrogen atoms that are found in the molecule or in one more of an acid, the hydrogens have been displaced. But now there are two things involved here. It's either the hydrogens are partly displaced or all of them are displaced or are replaced by a metal or ammonium ion, not ammonia, but ammonium. So these two words that I've highlighted, or partly, or part of the hydrogen atoms are displaced, this is going to help us in the identification of types of salts. If all of the hydrogen atoms are displaced, what type of a salt are we forming? If only part of the hydrogen atoms in in a molecule of an acid are displaced, or maybe just one is displaced with some or one more remaining, what type of a salt are we forming? So this is very important. A salt is a compound that is formed when all or part of the hydrogen atoms are displaced by a metal or ammonium ion. We know what metals are, such as zinc, aluminium, calcium, lead, and so on and so forth. So we can look at examples of salts. We can look at zinc chloride. Zinc chloride is an example of a salt. The other one, because this metal, zinc, is having a metal, and then the chloride is coming from the hydrochloric acid. The other one, we can have aluminium sulfate, which is an example of another salt. We can also have sodium hydrogen phosphate, sodium hydrogen phosphate, which is another type of a salt. So we can also have calcium, sodium sulfate. So we have zinc chloride, aluminium sulfate, sodium hydrogen sulfate, calcium sodium sulfate. So these are types of, so these are examples of salts that that we can say for now. But one thing you need to understand is that a salt should contain a metal or two metals and a radical. A radical is a negative ion which comes from an acid. So you're saying a salt should have a metal or metals plus a radical. But you need to understand that this radical is supposed to come from an acid. Just that is all you need to know. A salt supposed to have a metal or metals plus a radical, and this radical has to come from an acid. So if you look at zinc chloride, the chloride radical is coming from, the chloride radical is coming from hydrochloric acid. Then the sulfate radical in the salt aluminium sulfate is coming from the sulfuric acid. And then yeah, this one here, sodium hydrogen phosphate, the PO4, the phosphate radical is coming from the phosphoric acid. Same applies to this one here. The sulfate is coming from sulfuric acid. Now, having looked at the definition of a salt, having looked at examples of a salt, now let's try to look at types. Let's try to look at the types of salts. What are the types of salts that we have? Basically, there are only three types of salts that we're going to look at. There are only three types of salts that we are going to look at, and those types will be driven from the definition itself. The same definition that I've given you, borrowing those underlined words, will make us understand the types of salts. So let's look at the types of salts. Now, salts, so let's look at the types of salts. Now, there are basically three types of salts that we look at. There are basically three types of salts that we are going to look at. Basically, three types of salts that we're going to look at. The first one is a normal salt. Normal salt. Now, this salt is normal. It's not abnormal. I'm just trying to be funny. This normal salt is formed when all of the hydrogen atoms are removed, or all of the hydrogen ions are displaced or replaced by the metal from more of an acid. So we are saying this salt is formed when all hydrogen, when all hydrogen atoms are displaced, or replaced by a metal, or ammonia, or ammonium ion. So if you have an acid, when you have an acid, then the acid, of course, because for it to be an acid, definitely should have hydrogen ions within it. So when all of its hydrogen ions are displaced, in place of them, then the metal comes in. When all of the hydrogen atoms are displaced by a metal or ammonium ion, that type of a salt you're going to have is what we call a normal salt. So the example of how we can form these normal salts. A metal, we can speak of anything such as calcium. Calcium is our metal, Ca. Then this metal reacts with the, let's speak of phosphoric acid, the hydrogen, then PO4. It's only the phosphoric acid in our chemistry that we're going to look at, which has got three hydrogen atoms within it. Or maybe if you can allow me to replace the phosphoric acid with the sulfuric acid. With the sulfuric acid, which is H2, no, with the sulfuric acid, which is H2, then SO4. So during the reaction, in here, we understand that there are two ions of hydrogen which are combined with one more of the sulfate radical. This is what we have in here in the sulfuric acid. So what is going to happen is that the calcium is going to be bonded to sulfate, then kicking hydrogen to be liberated as a gas. So what's going to happen is that the calcium is going to be bonded to the sulfate, forcing the hydrogen to be released as a gas. So the completion of this equation can be written as calcium plus sulfuric acid to form calcium sulfate, then plus hydrogen gas. So if you look at this calcium sulfate here, this calcium sulfate, all of the hydrogen atoms that were attached to one more of the sulfuric acid have been removed. You see, where there was hydrogen, now we have got the calcium in its place. So this type of salts that are formed where all of the hydrogen atoms are replaced by one metal, these are the ones we are calling the normal salts. There are many of these examples that we can look at. The reaction between sodium and the hydrochloric acid to form sodium chloride, which is a common salt. There are many that you can look at. So you can have a sodium here plus hydrochloric acid plus hydrochloric acid here to form uh, sorry, plus hydrochloric acid, HCl. Then what are we forming? Remember, in here, we've got one ion of hydrogen, which is combined with one chloride ion. So what is going to happen is that this sodium is going to kick this hydrogen out of its compound, and then the sodium will be bonded to chloride to form sodium chloride, and then plus the hydrogen. So these ones are normal salts. So a normal salt is formed when all of the hydrogen atoms are removed from the acid molecule. There are quite a lot that we can talk about under normal salts, but all, in the normal salt, there is no hydrogen atom that is present therein. Then, having looked at this, let's also look at the other type of salts. The other type of salts, and this one is a little bit different from this because part of some of the hydrogen atoms remain within the salt. Okay, because part of some of the hydrogen atoms remain within the salt. So the first one was a normal salt. The other one is an acidic salt. But one thing you need to understand is that the ion responsible for the acidity of a substance is the hydrogen ion. The ion responsible for the acidity of a substance is the hydrogen ion. So that means in these salts, we are likely to find the hydrogen atom present in the salt compound. Why? That is what gives the acidic property of this salt. So these salts are formed when part of hydrogen atoms are replaced by a metal or ammonium ion. The ammonium ion is NH4 plus, which is the ammonium ion that we're talking about. We are saying it's an ion. We are saying a metal. We can have a metal like, such as zinc existing at room temperature and pressure, but such you never find them. They must be bonded to a non-metal such as ammonium chloride. So it's this one which is coming to displace, or which is coming to replace the hydrogen. It's the ammonium ion, not ammonium exists as a charged. It's a charged species. It's charged. It's different from these metals. These metals you can have a neutral metal, like the way I presented calcium. Calcium did not have a charge because it is neutral. So I say when part of hydrogen atoms are replaced by a metal or ammonium ion, how can we present this? By the way, these are normal sorts. So what we're going to have here is you can have, but be reminded that most of the times the salts that are used in here are either diprotic acid or monoprotic acid. What do I mean? No, mostly is diprotic and the triprotic acid. What do I mean? I mean those acids that have got more than one hydrogen, which form more than one hydrogen ion when they completely ionize. In short, whose basicity is more than one. Such acids are sulfuric acid, H2SO4. It has the basicity of 2. The other one is phosphoric acid, PO4. This guy here has a basicity of 3. The other one is carbonic acid, the carbonate. These guys have got, this one has got a basis of 2, basis of 3, basis of 2. So most of the times these are the acids that we use when you are forming acidic salts. You cannot use hydrochloric acid because hydrochloric acid is a neutral compound whose metal acid the hydrogen only has the basicity, the valence of 1. The chloride also the valence of 1. So when they combine, we're going to have a neutral compound. So there is no space where a metal can form for it to have hydrogen remaining within the molecule. But with this, you can have one hydrogen gone, then bringing in a metal whose valence is 1. So that the valence of that metal and the valence of this hydrogen can accommodate the 2 minus that is coming from the sulfate, because the sulfate has got a valency of 2. So how can we show the formation of these acidic salts? Speak of any metal which has got a valence of 1. We've got lithium, we've got sodium, we've got potassium. So I can use potassium this time around to match of sodium. Potassium, which is K, plus the acid I'm going to use is sulfuric acid, SO4. But what is it that is going to happen? In here, there are two hydrogen ions that are bonded to the sulfate ion. So we have 2 hydrogen, like that hydrogen ion, which are bonded to the sulfate ion. The sulfate, there is only one sulfate whose valence is 2, and the valence of 2 with one hydrogen, with one charge coming from hydrogen, positive charge, but there are 2 of them. So in here, okay. So just sorry about that. So that is how this thing is done. Now, what's going to happen here is that this sodium, this potassium whose valence is 1, is going to occupy the place of 1 hydrogen atom. So 1 hydrogen will go, and then we're going to have this potassium occupying that space where 1 hydrogen atom comes from. So we're going to have potassium hydrogen sulfate. Because this sulfate, remember, has got a valence of 2. Here, the valence of 1, valence of 1. 1 plus, 1 plus, 2 minus. They are going to combine. That's why this thing is not charged. Then plus C, hydrogen is formed. But all in all the group 7 elements such as chlorine, fluorine, iodine, bromine, all those hydrogen, the nitrogen, they exist as the diatomic elements. So you cannot find hydrogen alone like that unless it is charged. But because this is a gas which is liberated, we're going to have a 2 like that. But the question comes in, only 1 is removed. How come we have got 2? Remember, there are a lot of these molecules of sulfuric acid in the solution. So definitely 1 comes out, then another, we're going to have this salt, another salt. So this salt loses 1 hydrogen, another salt loses hydrogen, then hydrogen from one salt and hydrogen from another salt are going to combine to form a molecule like that. Okay, so that is how we can show the formation of the formation of acidic salts. Acidic, which is a potassium hydrogen sulfate. Which other one can we look at this time around? Let's use the phosphoric acid. So now this time around, we can use the metal which has got a valence of 2. Those elements that are in group 2 of the periodic table, such as calcium. This time around, I can use magnesium. So magnesium plus phosphoric acid, H3PO4. In here, we have 3 ions of hydrogen, which are combined with only 1 molecule of the phosphate. But we need to understand that this phosphate here has a charge of 3 minus 3, 1 single hydrogen ions. There are 3 of them. So 3 plus, 3 minus, when they combine, that's why this phosphoric acid is not charged. So once this happens, these guys are going to combine. Then this magnesium, like I said, has got a valence of 2. So it's going to remove 2 hydrogen from here, having 1 remaining. So the compound, the salt that will form is magnesium hydrogen phosphate plus hydrogen gas. But again here, be reminded that in here, this magnesium has got a valence of 2, then hydrogen has a valence of 1. When we combine them, they're going to have the valence of 3, which are being bonded to 1 more of sulfate radical whose charge is -3. So -3 plus 3, that's why the magnesium hydrogen sulfate is not charged. But be reminded again that if the metal that we used here had a valence of 1, that means we were going to have 2 hydrogen atoms remaining. I don't know if that's making sense. But what I'm trying to say is this: if the continuation of this, let me write it on top. What I'm saying is, if the metal used on the formation of an acidic salt using phosphoric acid as the acid, if it has a valence of 1, meaning it's going to displace only 1 hydrogen, having 2 remaining. So what I mean is, let's say sodium Na. Sodium plus phosphoric acid. So once we have that, in here there are 3. This guy has got a valence of 1. So it's going to remove only 1 hydrogen, and then you're going to have sodium hydrogen 2, then PO4 plus hydrogen gas. Why do we have 2 here? Because this guy has got a valence of 1. So has only removed 1 here. This guy has a valence of 2. That's why it has the capability of removing 2 hydrogens from here. There are 3. Once you remove 1, you're going to have 1 remaining like that. But should you use a metal which has got a valence of 3, such as aluminium, meaning 3 of them will go, like aluminium plus phosphoric acid, PO4, aluminium has got a valence of 3. So 3 of them will go. And the one that you're going to form, aluminium phosphate. Do you see? There is no hydrogen there. So that is a normal salt. it does not qualify to be called an acidic salt. We are saying acidic salts should have hydrogen atom within them. Okay, so yeah, so that is how we can form the these the acidic salts. Now, the last one is what we call double salts. Remember, we said these double salts have most of the times these are complex. These are complex metals, and the chemistry of complex metals, you don't do much of them when you're dealing with this physical science. You understand it, you understand them better when you go to the university, when you start looking at the ligand and then is it a bidentate, the monodentate, such and such. That's when you're going to understand them better. So I may not give an example of the formation or how we can form these double salts. But all in all, what I'm trying to say is that these metals, you need to understand the concept for the double salts. You need to understand a bit of the homo. It's a bit of detailed, so I may just leave here. But I can maybe just show you the example of double salts. Double salts, how they are formed. That is complex chemistry, and I'm afraid I may not go into detail. But if you want to learn about them, you can just let me know. I can give you some tips on how these complexes are formed. These complex salts, such as the one we're calling double salts, I can understand them better when you start looking at the complex metals. Complex metals such as uh, 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 hemoglobin. Hemoglobin is a complex of iron. That's why we say iron is very, very important in the transportation of oxygen. But for the hemoglobin to be formed, you need to have iron, which is the main metal, and then you're going to have the ligands bonded to it. And then the other complex that you can look at is the chlorophyll. Chlorophyll is a complex of magnesium. That's why for a green leaf to have its green color like that, it's because there is magnesium, which is there's a chlorophyll, which is a complex of magnesium. Now, with all that said, let me just give examples of double salts. These double salts here are quite a lot. And most of them, they have got the water of uh, crystallization. Now, these salts, maybe I can just give you examples of these double salts. Okay, so the examples of double salts that I can give you is okay. This one is kind of confusing for your chemistry. Like you can have an example of a double salt. Double salt. You can have such as I'm afraid this is pure chemistry. You can have FeSO4 and then dot. You can also have the ligand, which is NH4. No, it's not the ligand. Then 2SO4 plus the water of crystallization, which is that. But naming of such such salts, these double salts, you don't do them in the physical science. All right, so having looked at salts, maybe if we can just quickly also look at how we can form these these salts, yeah, the formation of salts. But these salts here, them being normal salt, them being normal salts, them being double normal salts, them being acidic, and so on and so forth. They are either soluble or insoluble. These salts are either soluble or insoluble. It's either they dissolve in a particular solvent, such as water, or they do not dissolve. And those that dissolve, we say they are soluble, and those that do not, we say they are insoluble. So maybe if you can just allow me to say, this salt that you see here, maybe that's where I'll end. This salt that you are seeing here, just pick a salt, then ask itself, ask it, you salt, are you soluble? If you are soluble, then if you are soluble, you can use a certain method to prepare. And if this salt is insoluble, the method that we're going to use is precipitation or double decomposition. Double decomposition. And if it is soluble, we can use the neutralization. We can use the neutralization, or you can react it maybe by a single displacement. Yeah. And so on and so forth. So next time that we're going to look at, we are going to focus much on the preparation of insoluble salts. These insoluble salts, such as lead 2 chloride, insoluble salts such as lead 2 chloride. How can we prepare them? By the method we call precipitation or double decomposition. There are quite a number